In this section, we will discuss how relationships are measured and tested using statistics. So often, as you know, in the medical literature, our goal is to answer some research question. And as we discussed in the study design section, this involves assessing how some exposure or treatment is associated with some outcome, like how healthy or happy a patient is. And so this relationship between the exposure and outcome is known as an association. An association is basically the relationship between two variables. So this can be an exposure and outcome, as we've previously discussed, or a screening test and disease, or more broadly, an independent variable and a dependent variable. So in statistics, we refer to this as X, the independent variable, and Y, the dependent variable. So these associations are measured using statistics, and then they're tested using hypothesis testing. And so this relationship that we're measuring, it can be causal, meaning the exposure causes the outcome. So returning to that chart that we went through in the types of statistical or types of scientific questions section, sometimes we're trying to estimate a causal effect. So we want to know how changing the average of one measurement affects another. So that is, sometimes associations are causal. And this picture that I've drawn here is actually representing a causal relationship. And we can tell that because I have this green arrow that goes directly from the exposure to the outcome. But it's also possible that the relationship between two variables may just be a correlation. And so it's possible that the exposure and outcome are correlated. So there is a relationship that exists between the two, but the relationship is not necessarily causal. So the exposure doesn't necessarily cause the outcome. So to show that, we usually use a bidirectional arrow to represent this type of relationship. So the two main ways to quantify an association are through the point estimate and some uncertainty. So in this section, we're going to focus on the point estimate. In the simplest case, the point estimate is the difference in means between two groups, or the difference in the average between two groups. Other point estimates that are commonly seen in the medical literature include the correlation between two variables, a coefficient from a regression model, an odds ratio, a relative risk, or hazard ratio. We're going to discuss these different types of point estimates in more detail in the statistical models section. But for now, let's just focus on the simple case when our point estimate is a difference in means, or the difference in the average between two groups. So let's say we've taken a sample of two groups like we discussed in our data collection section, and we're interested in knowing if those two groups, if the people in those groups have equal heights. So we can measure the height in the green group and measure the height in the blue group. And we find that on average, the green group is 68 inches tall and the average height in the blue group is 61 inches. So this seems to suggest that the green group is taller than the blue group. And the point estimate here is going to be 7. So 68 minus 61, or the difference between those means, is 7. So that's going to be our point estimate here for the difference in heights. Okay, so coming to a real example, here researchers are interested in assessing the relationship between alcohol control policies and alcohol consumption. You can find this article in PLOS Medicine by following this link here. So here they want to know if there's a relationship between this alcohol policy score that they've come up with and an annual per capita alcohol consumption. So as that score goes up, what is the relationship with the amount of alcohol that's consumed per person per year in each country? And so they calculate a point estimate here. So they state that the point estimate is negative 0.1. And notice here they say that the text refers to this as the slope of a regression line. So we're going to get more into that in the statistical models section. But basically that point estimate that they show is negative 0.1. And then they go on to describe that this signifies a decrease in consumption of 1 liter of absolute alcohol for each 10-point increase in the score, in the alcohol policy score. So that 1 liter of absolute alcohol can also be referred to as a point estimate. Basically, they've just multiplied that initial slope or that initial point estimate by 10. We're going to be using this example more in the subsequent lessons to talk about uncertainty and then finally talk about hypothesis testing.